2I sub x one K, 1 kilo ohm, 1 K, I sub x is right here. $12 1K, and V out is right here. And we have a current source coming down on the top, 2 milliamps. That's my circuit. So what I'm going to do is cut the circuit right here. And replace the rest of the circuit. So if I draw a box here around it,
how do you decide where you're going to?
Where the load is, we're trying to find. Trying to find V out. So I'm going to leave V out here.
Well, what if there isn't like a resistor by the load that you're trying to find?
Whatever you're trying to find. They have to give you something, trying to find there. And replace that with R Thevenin and V Thevenin. Which means I got to find the equivalent of this circuit, the one in red. I'm going to replace that, what you see in red there, with one source called V Thevenin, one resistor R Thevenin, and it's going to be connected right there. And the R load, which is that's this value, trying to find V out, that's the 1K, is right there. The right circuit? Yeah, that's the right circuit. Okay. So let's find V Thevenin, which is V open circuit, and probably wise to go on the next page and redraw everything on the next page. So this is trash. Draw them a little bit small there. One K, two milliamp, 1,000, and that's V open circuit, plus to minus. I sub x is right here. And now let's find it. How do we find what V open circuit equals to? It's actually much easier than what you think. If I do a KVL right here, just into this loop, let's look at that. Plus to minus, that's what? Plus V open circuit, right? Plus to minus, plus 12. Currents go in this direction, is going to mark it plus to minus, right? Plus 1000 I sub x equals 0. So what's V open circuit equals to?
Well, you don't need to account for the.
I sub x, I define the current. I sub x is the current going that one.
Gotcha.
So it's negative 12 plus, be a minus, right? Because you're moving it to that side. So if I know my I sub x, I'm done. If you look at KCL at this node, right at this node, what did KCL say at that node? Sum of the current entering that node is 0. What is the current entering the node here? I sub x plus 2 milliamp equals the current leaving. What's leaving that node? Nothing. So what's I sub x equal to? Negative 2 milliamp. Do you know what V open circuit now is? Negative 10 volts. That's what V Thevenin equals to. It looked much worse, but when you start doing it, oh, it's not bad actually. Next, what are we going to do?
R Thevenin.
We need to find R Thevenin. So we found V Thevenin. So what's R Thevenin? R Thevenin, when you have an independent and dependent sources based on my notes, it's V open circuit over I short circuit. So I need to find I short circuit next. And what's I short circuit? We take a wire and attach it right there and calculate the current going through it. So let's redraw that. Two I sub x, 1K, one K, 2 milliamp. Now we're going to put a wire here, short circuit. This is I short circuit. One K. This is I sub x, in case you forgot. Now let's think about this problem. Again, it looks ugly, but really if you think about this, if this is your ground, the bottom is your ground, what's the voltage right here? What is it? Negative 12, good. If this is ground, what is the voltage here? Zero. Ground, same node. Do we know what I sub x is? I sub x defines the current going that direction, so negative 12 minus 0 over 1K, which is negative 12 milliamp. KCL of this node. KCL says what? The current entering the node, if you add all the current in, equals all the current out. What is going to that node? I sub x. What is going to that node? 2 milliamp. And what's leaving that node? I short circuit. Negative 12 milliamp plus 2 milliamp equals I short circuit. What's I short circuit? Negative 10 milliamp. R Thevenin, it's V open circuit over I short circuit. And V open circuit, what was it? Negative 10? Negative 10 volts. I short circuit, negative 10 milliamp. What's that? 1,000? 1K? So now this ugly circuit that you see here, in two couple of simple steps, I'm replacing that with a voltage source of the value of negative 10 volts, right? R Thevenin, which is what? 1,000. And this is 1,000. And what's V out? Isn't that voltage division? Negative 10 times 1,000 over what? 2,000? Negative 5 volts. When you look at it, really it wasn't easy, but when you find the shortcut, when you see some stuff, goes, oh, I can do it this way. And the third scenario, what happens when you only have dependent sources? So I told you 3 different ways. Let's look at the third one. When you have dependent sources only, find the Thevenin equivalent of the circuit below. I have 2 I sub x, dependent source, 1K, 1,000, another 1K here, $1,000, $1,000, and there's the load resistor right here. Let's put a value called R sub L. Doesn't really matter what the value of that, because I'm just finding the equivalent of what's to the left there. And I sub x happens to be this current. I want to find the equivalent of this circuit. Here's the good news. When you only have dependent sources, because if you cut that circuit, this is what you have. When you only have dependent sources, the V open circuit is going to be 0. So you're only going to find R Thevenin. You're not going to find V Thevenin. There is no V Thevenin here. So in this case, when you only have dependent source, you're going to add a voltage source or a current source. Excuse me. Thank you. Thank you. So you can add a voltage source or a current source, up to you. If you add a voltage source, maybe 1 volt. If you add a current source, he's at 1 amp, 1 milliamp. Because of the 1,000, he may be 1 milliamp. So maybe, in this case, I will add 1 current source. The reason I chose current over voltage source, why? Anyone?
Because you have current already defined, and I sub X, it's like...
No, I was looking right here. I can do source transformation, right? Simplify that and get this value. So that's one reason. So what you want to find is the voltage here, because if you know what that voltage is, R Thevenin is going to be the voltage divided by 1 milliamp.
Wait, so why did you choose 1 milliamp? Can you just choose any number?
I didn't number. Doesn't matter what the number is, because usually I choose 1 to make the math easy, but because this is in a K, if you use, for example, 1 amp, if you do source transformation, what's 1 times 1,000? You have 1,000 volt, you know? So that sounds silly that we don't deal with that high voltage. So if I use 1 milliamp, what's 1 milli times 1,000? 1 volt, that's more reasonable. I could use 5 milliamp, 5 milli times 1,000, that's 5 volts, but something reasonable. And if you look at that, you really have 2 nodes. This is node 1. And this is node 2. I can do KCL at each node, and I have 2 equations by 2 unknowns, and I'm done. Let's look at KCL. At node 2, right there. Let's define current. I'm calling this voltage V, right? So that's V2, let's call it V2 here. So V at node 2, V at node 1. That V2 is really that V here. So if I find V2, it's V. The voltage right here. I decided to call V at node 2. If you look at the current in, equals the current out. Which way you want to define these currents? You want to make it go this way, and this way, and this way? At this node, what's the current going in? V1 minus V2 over 1K. What else? 1 milliamp equals the current leaving, which is what? V2 minus 0 over 1K. So when you multiply by 1,000 or 1K, you have V1 minus V2 plus 1 equals what? V2. So the first equation, 1 equals negative V1 plus 2V2. Next, KCL at V1. What is the current going to it? Nothing. Zero going to it, what's leaving? This one, 2I sub x plus V1 over what? 1,000. 1K. I sub x is coming down plus V1 minus V2 over 1,000. I already had equals 0 there. I don't have to write it twice. And what's I sub x, by the way? Isn't I sub x v1 minus 0 over 1,000?
Yeah.
So if I plug it in here, I have 2v1 over 1k plus v1 over 1k plus v1 over 1k plus v1 minus v2 over 1k. My LCD is what? 1k, 2, 3, 4, 5, which tells me what? v2 equals 5v1. And there's my other equation. Plug it in. 1 equals negative v1 plus 2 times v2, which is 5v1. v1 equals 1/9. What's v2? 5 times that? V2 happens to be the voltage V, right? That's V, which is V2 between ground and that node. So that's what V is equal to. So what's R Thevenin? Equals the voltage, which is 5 over 9, divided by the current, which is what? 1 milliamp, which is 5 over 9 kilo ohms. So I can take that circuit right there, replace it with one resistor with the value 5 over 9 kilo ohm. There is no voltage. The voltage is 0. And that's how you find the equivalent circuit when you only have dependent sources. V open circuit, or V Thevenin, will be 0, and R Thevenin will be the voltage divided by the current. You can assign any number you want to there and calculate the voltage.